Did you know that every day, a whopping 3.2 billion AA and AAA batteries are churned out globally? That's around 1.2 trillion batteries annually. Yet a startlingly small fraction, only about 5%, are actually recycled. The rest? They wind up in landfills, where their harmful chemicals leach into the soil and water, causing environmental havoc. You see, recycling batteries isn't just a feel-good gesture. It significantly reduces the environmental impact by recovering valuable materials and keeping toxic substances out of our soil and water. So, if you're curious about how we can flip the script on battery waste and make a difference, stick around, because we're diving into an electrifying process that might just make you rethink tossing those old batteries away. Step 1. Collection. When it comes to recycling AA and AAA batteries, the journey starts with us, the consumers. Those little power packs that fuel our remotes, clocks, and gadgets eventually run dry, but they don't belong in the trash. Instead, the first step in their recycling journey begins at collection points. These are conveniently placed in locations you probably visit often, like supermarkets, electronics stores, and designated recycling centers. Governments and environmental organizations have been ramping up efforts to make these collection points more accessible. For instance, in the UK alone, there are over 30,000 battery collection points available to the public. In the US, the Call to Recycle program has established over 16,500 drop-off locations nationwide. The aim is to make it as easy as possible for everyone to drop off their used batteries, rather than letting them pile up at home or end up in landfills where they can leak harmful chemicals. Public awareness campaigns and even incentives like discounts or rebates for returning old batteries are also part of this step, encouraging more people to take that first step towards responsible battery disposal. Step 2. Sorting. Once those old batteries reach the recycling facility, it's time to get them sorted. You see, not all batteries are created equal. You've got different chemistries, sizes, and types, each requiring a unique recycling process. The goal here is to ensure that only similar batteries go through the same recycling path, optimizing the efficiency and safety of the process. At the facility, the batteries are first separated by size and type using advanced sorting machines. These machines use techniques like conveyor belts, magnets, and even infrared sensors to distinguish between different kinds of batteries. AA and AAA batteries are grouped together, but they might be further sorted by chemistry, like alkaline, zinc carbon, or rechargeable nickel metal hydride. In some facilities, manual sorting is still a part of the process, especially for batteries that might confuse the machines. Workers carefully check and sort these batteries to avoid any potential mix-ups. Step 3. Shredding. After the batteries are sorted, they head to the shredding stage, where things really start to get interesting. The batteries are placed into a specialized machine designed to break them down into much smaller pieces. Shredding is done in a controlled environment because of the potentially hazardous substances inside these batteries. When AA and AAA batteries are shredded, their metal casings, internal chemicals, and plastics are all separated into different fractions. The process ensures that any potentially harmful components, like the electrolyte, are handled safely to prevent leaks or contamination. These machines are powerful, yet they operate with precision to avoid any uncontrolled release of harmful substances. The shredded output, often referred to as battery scrap, consists of a mixture of materials including steel, zinc, and something called black mass. This black mass is a critical component, as it contains valuable metals like manganese and lithium, which will be extracted in the later steps. Step 4. Separating metals. After the batteries have been shredded, the next step is to separate the valuable metals from the mix of materials. This is where the recycling process really shows its mettle, pun intended. The goal here is to isolate metals like steel, zinc, and manganese, which are key components of AA and AAA batteries. The shredded battery scrap is put through various separation processes, which combine mechanical and chemical techniques. One common method involves using magnets to pull out steel and other ferromagnetic materials from the mix. Steel, being the most abundant metal in these batteries, is relatively easy to separate this way. It's then sent off for further refining and can eventually be reused in the manufacturing of new products, including new batteries. The remaining non-ferrous metals like zinc and manganese require a bit more finesse to extract. Here, a combination of chemical baths, sieves, and other separation technologies come into play. These methods help isolate zinc and manganese, which are then processed further to reach the purity levels needed for reuse. This separation is crucial because these metals are not only valuable, but also finite resources. Recycling them reduces the need for new mining operations, which can be environmentally damaging. In fact, recycling a single AA battery can save up to 80% of the energy required to mine and produce these metals from raw materials. Step 5. Refining the black mass. So after the metals like steel, zinc, and manganese are separated, we're left with the black mass. Now this isn't just any leftover, it's the heart of the battery recycling process, containing some of the most valuable materials, namely lithium, cobalt, and nickel. These elements are essential for creating new batteries, especially in today's tech-driven world where demand for rechargeable batteries is skyrocketing. The black mass undergoes either hydrometallurgical or pyrometallurgical processes to extract these precious elements. Let's break that down. Hydrometallurgy involves using liquids, often strong acids or bases, to dissolve the metals. This solution then undergoes various purification steps to separate the different metals. On the other hand, pyrometallurgy uses high temperatures to melt down the black mass, allowing the metals to separate based on their different melting points. It's a fiery process, but effective in isolating metals like cobalt and nickel, which are then refined further. Without this step, the recycled materials wouldn't meet the strict standards required for battery production. This part of the process not only recovers valuable resources, but also significantly reduces the environmental impact compared to sourcing new raw materials. Step 6. Making new batteries. Once the metals and other materials have been extracted and refined, they're ready to be transformed into brand new AA and AAA batteries. This is where the recycling loop closes, turning what was once waste into a fresh product ready to power up your devices. The refined metals, such as lithium, cobalt, nickel, zinc, and manganese, are sent to battery manufacturers. Here, they're used to produce new cathodes, anodes, and other critical components of batteries. This process involves mixing these metals with other elements to create the exact chemical composition needed for the batteries. Each component is carefully engineered to ensure the final product delivers the same performance, safety, and longevity as batteries made from virgin materials. This stage is all about precision. The materials need to be mixed in exact proportions and then formed into the various parts of the battery. The cathode and anode materials are applied to metal foils, which are then wound or stacked into the familiar cylindrical or prismatic shapes we know. Step 7. Quality control. After the refined materials from recycled batteries have been transformed into new batteries, the next critical step is quality control. At this stage, manufacturers put those newly produced batteries through rigorous testing to ensure they meet all the necessary standards for performance, safety, and durability. Quality control is no small task. The batteries are subjected to various tests that measure their voltage, capacity, and charge retention. Essentially, the manufacturers want to make sure that these recycled batteries are just as powerful and reliable as those made from entirely new materials. For instance, a common test involves repeatedly charging and discharging the batteries to simulate real-world usage. This helps to ensure that they can withstand the wear and tear of daily use without losing their effectiveness. In addition to performance tests, safety checks are also paramount. Batteries are tested under extreme conditions, like high temperatures or physical stress, to confirm that they won't leak, overheat, or pose any other risks when in use. In 2023, advancements in battery technology allowed recycled batteries to match the performance and safety of their non-recycled counterparts, with some manufacturers achieving a 99.9% pass rate during quality control. If a recycled battery doesn't perform as well as a brand new one, it could discourage people from supporting battery recycling efforts. But thanks to these thorough quality control processes, consumers can be confident that the recycled batteries they're purchasing are just as good as, if not better than, their new counterparts. Step 8. Packaging and distribution. Once the batteries pass all the quality control tests, they're ready for the final step, packaging and distribution. The batteries are carefully packaged to ensure they stay protected until they reach consumers. After packaging, the batteries are shipped out to retailers around the world. They find their way onto store shelves, ready to power everything from your TV remote to your wireless mouse. It's here that the cycle truly completes itself. The old batteries you dropped off at a collection point have been reborn, now ready to power up someone else's device. This final step also involves a bit of marketing. Companies often use labels or packaging inserts to inform consumers about the recycled nature of the batteries. It's an opportunity to educate the public on the benefits of battery recycling, reinforcing the idea that choosing recycled products helps reduce environmental impact and conserve natural resources. In recent years, there's been a growing trend among consumers to choose products with a smaller carbon footprint. According to the 2023 Buying Green report, 70% of consumers said they are more likely to buy a product if they know it's made from recycled materials. Another study from Stena Recycling also reported that a large majority of consumers view the use of recycled materials as important, with 76% expressing that manufacturers must use recycled content in their products. And so, the journey of AA and AAA batteries comes full circle. From the moment they're collected at drop-off points to the rigorous testing they undergo, every step ensures that these recycled batteries are just as good, if not better, than their non-recycled counterparts.